You don't have to be in the front row. Hey everyone. Hey Chris. Um, Thanks to Ben and Espresso for having me. Thanks to everyone for coming. Um, I just want to clarify before I get started that I made these slides myself, and so what you're seeing is not a lack of effort. It's just a lack of talent. Um, so what I'd like to go through today is kind of what we're thinking about aggregated blockchains, the thesis, how the AggLayer works at a very high level, and then how it can connect to shared sequencing and kind of what everyone else is focused on today. So I think like at a very high level, one way to think about aggregation is initially we had the monolithic blockchain thesis. And so that was the idea that we could scale with a single chain and that in fact scaling with a single chain was the best way to scale because it scaled in a way that's meaningful, which is it scaled access to liquidity and to shared state. And so rather than just adding block space sort of ad hoc, it's much better to scale on a single chain like Solana because it gives you increased access to liquidity and to shared state. I think that where the modular thesis came in was the realization that actually a single chain cannot scale to sort of this ambitious internet scale vision of crypto that we have, and moreover that different applications have different requirements for security and decentralization and user experience, and it's sort of unrealistic in some sense to expect that a single chain can accommodate those heterogeneous requirements from applications and developers and users. Where I think the modular thesis falls short is that if you look at the current state of Ethereum, we have a ton of rollups. And across all of those rollups, I'm sure as other people have discussed today, we have fragmented state and liquidity and user bases. And so the problem is if you're a rollup developer, you have to not only build your custom execution environment and focus on this thing that gives you leverage or a specialized advantage, but you also have to play games to bootstrap liquidity and to bootstrap users. And so it's not like a very capital efficient or very like time or sort of like developer efficient strategy to scaling Ethereum, because not only do we have to build a custom execution environment like the SVM or some cool zkVM, but we actually have to attract liquidity and users to that rollup. And so I think it just like doesn't allow developers to specialize in sort of their comparative advantage. And so the aggregated thesis is this idea that we should be able to scale horizontally, but we should be able to do it in a way that preserves shared access to unified liquidity and to shared state and to composability. So this is sort of the current state of the Polygon ecosystem, but you could easily read it as being the current state of the Ethereum ecosystem, where we have a bunch of L2s. They're all fragmented, and there's no easy way to trustlessly bridge state or liquidity between those chains. Actually, I'll go to this one. Because the requirement for trustlessly bridging assets is like let's take bridging from zkVM to like Arbitrum or to zkSync. It requires me initiating a transaction on zkVM, waiting for that proof to be generated, waiting for that proof to be verified on Ethereum, waiting for that block to be finalized, depositing to Arbitrum or to zkSync, and then waiting for the deposit block to be finalized on Ethereum before my funds are credited to me on zkSync. And so, like, we're trying to build this seamless internet of value that can scale to 1 billion people, and having hour-long latency between two like different execution environments is not a great way to do that. So if we think about, like, in my mind, what unified liquidity requires, it's two things. So first is asset fungibility across chains. So if I have like ETH on zkVM, I should be able to get ETH on zkPOS or get ETH on like the OKX chain in the Polygon ecosystem. I shouldn't have to worry about wrapped synthetic assets where I might have to pay a penalty for like a lack of liquidity on the destination chain in order to get to the native version of that asset. And second, I should have super low latency for asynchronous and synchronous composability across chains. So I should be able to have my funds on zkVM and bridge them to a chain that has really deep liquidity for like the ETH USDC pair, be able to swap, do some crazy degenerate DeFi stuff on that destination chain, and then swap back to the origin chain in like a very, very small amount of time. Certainly not the hour that it would take in the current state. So the AggLayer is an attempt to kind of solve this problem. And the way that I would describe the AggLayer, especially when Ben is sitting like 6 feet away from me, is it has two components. It basically has this, like the component that Polygon is building, which is this cryptographic guarantee of safety for cross-chain transactions at lower latency than Ethereum finality. And then there's this component that like Ben and other teams in the space are building, which is the actual coordination mechanisms that do cross-chain execution on top of the AggLayer. So that's like shared sequencers, relays, builders. And so it's like the cryptographic guarantee, the unified bridge, and then above like this emergent coordination mechanism ecosystem that's like really depends on things like shared sequencing. So in terms of how the AggLayer works, in the asynchronous case, it's really, really simple. Like if I'm receiving a message, if I'm on chain B, or yeah, if I am chain B, and I'm receiving a message from chain A, I'd like to be able to do that at lower latency than Ethereum finality. But the problem is there are basically two issues. First, the state that I'm depending on of chain A could be invalid. But even if it's valid, even if I'm able to verify a proof, there's still this risk that chain A could provide one state to me that's valid, and they could generate another state that's also valid and settle that state to Ethereum. And so I need this guarantee of protection that if I'm depending on a cross-chain message that that's not been finalized on Ethereum, I need a way to guarantee safety that my block will only be finalized on Ethereum if and only if the like block that I depend on from chain A is also finalized to Ethereum. So in the asynchronous case, it provides this strong guarantee of consistency that allows me to safely operate at low latency. The atomic case, to like really simplify, is similar. I can take a bundle of transactions that are executed across many chains, and as a chain, I commit to the bundle, and my updated chain batch is accepted by Ethereum if and only if all transactions in that bundle executed successfully across all chains. And so this is really important because if I have like a bundle that's doing like a burn and then a mint transaction across two chains, I can't mint on chain B if the burn on chain A wasn't successful, or else the bridge becomes under collateralized because I have like funds, new funds on chain B, but my old funds on chain A never went away. And so in the synchronous case, this basically adds another layer of cryptographic security to like what shared sequencers are doing, or what relays or what builders are doing. So yeah, this is sort of how I see it. Like the AggLayer is this piece of foundational infrastructure, but what it really does, and sort of I think why it's important is that it unlocks the ability for other projects and other pieces of infrastructure to be built on top in a safe way. And so that's obviously playing to the crowd, like shared sequencing, it's relays, builders, and I think it allows chains to make trade-offs that make sense for them. So we'll discuss like some of the like potential failure modes and like why, like what could go wrong if you're interoperating at lower latency than Ethereum. But I think the thing to sort of keep in mind is that like this design allows chains to navigate the trade-offs that sort of fit their use case. So some chains might only need asynchronous composability. Some might need synchronous composability. And so that dictates whether you need to use a shared sequencer, whether you can depend on a relay. And so I think it's really important that across the ecosystem, we have safety for all chains that's guaranteed cryptographically, both in terms of the consistency of chain states across the asynchronous and the synchronous cases, but also because we're sharing a bridge, we get safety even though we're supporting heterogeneous execution environments. So this is like maybe a little bit of a detour, but because Polygon is like a heterogeneous environment for provers and for execution environments, like we have the ZKVM type 1 and type 2, we have Miden. We're going to have future ZKVMs that are custom built for applications like a CLOB. You could imagine designing a super efficient CLOB execution environment in Rust, compiling it to a general purpose ZKVM, and basically getting the prover for free. And so this is like an amazing vision, and it's something that I think will be really important for this space, but it opens this risk where, if we're allowing chains to deploy permissionlessly and access a shared bridge and a shared pool of liquidity, if we're allowing like shit chain number 1000 to deploy their unsound prover, we need to guarantee that only that chain can be rugged by the unsound prover, that like a soundness issue with the prover cannot drain the entire ecosystem of all funds. And so this is another sort of safety guarantee that the AggLayer provides. So I think one thing that's come up when people have seen this proposal is like what happens if chain A does equivocate. And so chain B cannot be finalized on Ethereum and has to like reorg or has a liveness failure. And so the response to this, I would say, is that if you are interoperating at lower latency than Ethereum, you basically have to make this choice, which is either you guarantee safety and you risk that if a chain equivocates or if the AggLayer misbehaves or a shared sequencer misbehaves, that there will be a liveness issue, or you don't guarantee safety and you'll never have reorgs, but you do have the possibility that like a shared sequencer or the AggLayer itself can unbundle an atomic bundle of transactions. And so I think that like from my perspective, it's a better trade-off to guarantee safety, but you do have to pick between, at least in my view, you have to pick between these two options if you are operating at lower latency than Ethereum. So yeah, I would say not to be toxic and negative, but this vision is not available to optimistic rollups. Like if you're going to trustlessly bridge between optimistic rollups, you have to wait for the duration of the challenge period. Unless you're making some different trust assumptions. I mean, maybe Ben would correct me, but. Yeah, so I would say that's a great question and a great selling point for Polygon. I think it would just be a ZK rollup in that case. And so, like, it would just be, like semantically, I would consider that to be a ZK rollup. Yeah, totally. Or you could use the type 1 prover. I just think in that case, like once there are proofs, then it's no longer like an optimistic rollup. But definitely like the end goal for us with the type 1 prover and with like a lot of the ZKVM stuff is to take all of this liquidity and state that's currently fragmented across optimistic rollups and to onboard them into the AggLayer. And so that's like a main goal for Polygon. So what does this all amount to? I think it's like a horizontally scalable internet scale crypto ecosystem where, like I said earlier in the talk, like as a builder or developer, you get to focus on what's important to you. Like if you're building a new DeFi primitive that runs in a custom execution environment, or you're building a new NFT mint, or I don't know, a game or something, like you shouldn't have to focus on bootstrapping liquidity on your chain in order to deliver a good user experience. And so in this model, you can permissionlessly join Polygon. You don't have to like use the Polygon token for staking or for gas or for sequencing. Like there are no restrictions on any chains that participate in the AggLayer, but you can tap into existing liquidity, and in return, you can bring the economic value that you're providing as a builder. So your cool game or your DeFi primitive or your NFT mint. And so like in my mind, and obviously I'm very biased as I work at Polygon, but this is a purely positive sum transaction for builders and developers and for the Polygon ecosystem. Like the Polygon ecosystem benefits from like things that actually produce positive economic value, like NFT mints and games and DeFi primitives, and those builders get to instantly tap into existing liquidity. And so I think that this is sort of like the future direction for Ethereum, and it's something that like we're really excited to build alongside Espresso, shared sequencing, and other people in this room. But yeah, thanks everyone, and I guess there's no Q&A, but yeah, really appreciate your attention.